Hello students, so we had solved till question 35. Okay, so we are going to solve today question 36. So you have to find that is you have to evaluate these two integrals. There is a or, so option is there. Okay, let's solve the first one. Integral 2 cos square x plus cos x upon sin x minus 2 sin square x plus 3 dx. Okay, so I'm going to take cos common of x plus 1 dx upon sin x minus 2 sin square x plus 3. So if we look at the denominator, then we can say that we can convert this into partial fraction. Okay, so by substituting, put sin x equal to t. So taking the derivative, cos x dx equal to dt. Okay, and yeah, then cos x dx equal to dt, but this cos x remains, right? So that we have to convert it into t. So sin x is equal to t, sin square x is equal to t square. 1 minus cos square x is t square. So cos square x is 1 minus t square. So cos of x is root of 1 minus t square. So in place of cos of x, you can substitute root of 1 minus t square. Okay, so let's put into the integral 2 root 1 minus t square plus 1 cos x dx is dt upon sin x minus 2 t minus 2 sin square x plus 3. Okay, so we can write this as 2 integral root of 1 minus t square dt upon t minus 2 t square plus 3 plus integral 1 upon t minus 2 t square plus 3 dt. Okay, now this is I1, this is I2. Okay, now I1 integral is very difficult to solve because here root is there. Okay, so in this solution you are expected to solve only I2 integral. Okay, so we'll solve only the I2 integral. So using partial fraction, 1 upon t minus 2 t square plus 3 a upon t minus 2 plus bt plus c upon t square plus 3. Okay, so this is 1 equal to a into t square plus 3 plus bt plus c into t minus 2. Okay, so if we substitute here t is equal to 2, we'll get this second term equal to 0. So 1 equal to a t square 2 square 4 plus 3, so this is 7a, right? So a is equal to 1 by 7. Okay, now if we take this a inside, so coefficient of a coefficient of t square, or we can compare the constants. So constant is 1, here it is 3a. For this term the constant is minus 2c. Okay, substituting value of a, okay, right here 1 by 7. So 2c equal to 3 by 7 minus 1. So it is minus 4 by 7 So C is equal to minus 4 upon 7 into 2. So C is minus 2 by 7. Okay, we got C. Now we have to find B. So comparing the coefficients of t square. So here it is 0, a t square, so a, and bt square, so plus b. So b is equal to minus 1 by 7. Okay, now you have to substitute in this equation. So substituting over there, you will get integral a is 1 by 7 upon t minus 2 dt plus integral b is b we got minus 1 by 7 t minus 2 by 7, which is c, t square plus 3 dt. Okay, so this becomes 1 by 7 log t minus 2. Okay. Then minus 1 by 7 integral t upon t square plus 3 dt minus 2 by 7 integral 1 upon t square plus 3 dt. Okay, so this becomes, here you can multiply by 2 and divide by 2, so that the derivative of this term is 2t, right? So you can directly write 1 upon 14 log t square plus 3. Okay, and here you can write this as root 3 square. So this is a square plus x square, which is tan inverse 1 by a tan inverse x by a, so t by a plus c. Okay, now substituting the value of t, which is sin x, you will get 1 upon 7 log sin x minus 2 minus 1 by 14 log sin square x plus 3, then minus 2 upon 7 root 3 tan inverse sin x upon root 3 plus c. Okay, so let's solve the OR question, that is optional one. Find integral cos inverse root of x dx. Okay, so I'm going to substitute here t is equal to root of x. Okay, so its derivative is dt 1 upon 2 root x dx. Okay, so dx you can write it as 2 root x dt. So in place of root x you can write 2t dt. Okay, let's substitute this in the integral. So cos inverse t dx is our 2t dt. Okay, now we have to use UV rule, that is integration by parts. Okay, so this is cos inverse t, 2 we can write outside, integrating t dt minus integral of d by dt of cos inverse t into integral of t dt. Okay, so this is our u, this is our v. u v dash u integral of v minus derivative of u into integral of v. So this is integral of t is t square by 2 minus derivative of cos inverse t is minus 1 upon root of 1 minus t square into this is t square by 2 dt. Okay. T into t square by 2 minus into minus, this becomes plus integral t square upon root of 1 minus t square dt, and 2 half you can write here. Okay, this we are keeping as it is. Here I'll write t square minus so we can subtract 1 and add 1 here. Root of 1 minus t square dt, okay, plus half. So I can write this as 1 minus t square minus root of 1 minus t square plus 1 upon root of 1 minus t square dt. Okay, so if we rationalize this term, you can take this root in the numerator. So this is minus half integral 1 minus t square dt minus plus half integral 1 upon root of 1 minus t square dt. Okay, so taking the integral, this is our t by 2 root of 1 minus t square, this is a square minus x square formula, plus half sine inverse of t. Okay, plus half, this is 1 upon root of a square minus x square, which is sine inverse of t by 1, so t plus c. Okay, now we can substitute our t we had taken root of x, so we can write here t square root of x square, so x by 2 cos inverse of root x minus half root x by 2 1 minus x plus half sine inverse of root x plus half sine inverse root x plus c. Okay, so this is the last answer.